Drugs in the bloodstream decay according to this equation. So this is a separable differential equation. So let's divide y from both sides, or in other words, you can think of it as multiplying y1 over y, whichever one's easiest. So this is 1 over y with respect to y equals c times c, and then with respect to x. And we can evaluate the indefinite integral of both sides. So that's natural log y equals x times c. Oh, sorry, and I forgot, plus an arbitrary constant, plus an arbitrary constant. It's different, but then we can combine those. That's x times that constant they gave us at the beginning, c, and then plus, yeah, you could say c3, a different arbitrary constant when you combine these two, and then raise both sides on top of the power of e. So e natural log absolute value of y equals e the power of x times c plus c to the c sub 3. And so that simplifies to be y equals, so we got it by itself, and let's use the book's notation. This is c3 times e to the x times c. So a lot of students that have been doing the text are good here, but then they're not sure, because they got two different arbitrary constants. But think about what c sub 3 represents in real life. Because if you were to plug in, this is e times x times c. Because if x is time, I guess you could have used t for time too, but if x is time, if you plug in 0, like at the start, that's your initial concentration of the drug in the bloodstream. So when x equals 0, this is like our initial value. So this notation helps. Okay, this is y sub 0. It helps us because this next part says there's a half-life of the drug is 2 hours. So when you have half of the initial amount, you've gone 2 hours. So I'm plugging in 2 in for x, which was my time variable. And now if you divide both sides by y sub 0, you get 1/2. And then use a natural log to both sides. And so let's see, that's natural log 1 minus natural log 2 equals 2 times c. Natural log of 1, what power do you raise e to make it equal 1? Well, that would be 0, so this is just negative natural log 2 over c, over 2 equals c. There we go. Okay, so now that we have c, and just note this is negative 1/2 natural log of 2. Or put another way, if you use your properties of logarithms, this is natural log 2 to the negative 1/2 power, because a coefficient of a logarithm can become an exponent of that argument. And then yet another way is that this is the natural log of 1 over 2 to the negative 1/2 power. 1 over 2 to the 1/2 power. We moved it downstairs to make it a positive exponent, which means it is natural log 1 over the square root of 2, because a 1/2 power means a square root. So that's what c is when we simplify it. Okay, so let's see what we can do. What does our equation look like now? Y sub 0 equal, so y sub 0 times e. I'm going to put c first. C was natural log 1 over square root of 2. Natural log 1 over square root of 2 times x. So now we're ready to answer the question. The amount we have is equal to the initial amount in the bloodstream times e to the natural log 1/2, and then they're saying at time at 4 hours for my question, so I'm plugging in 4 in for x. So it looks like we got two variables, but it's asking for the fraction left over, so I'll show you what that means in just a second. This is going to be, we can rewrite this a little bit so that we can have an e and a natural log cancel out. They can't yet, This is e to the natural log 1 over square root of 2. Forgot the square root symbol. All to the 4th power. And now that it's just e to the power of natural log, those can cancel out. So we have y sub 0 times 1 over the square root of 2 to the 4th power. And so that means y equals y sub 0. And this is 1 over square root of 2 times 1 over square root of 2. So, or in other words, that's the 2 to the 1/2 power raised to the 4th power. So that means that's 1, oops, don't know why I have an equal sign there. 1 over 4. That's what this is. Double checking. Kind of tired. Okay, and so they're asking for the fraction left over. So the fraction right now, divided by the initial amount, that's the fraction left over. So that's the answer to their question, okay? The amount you have right now, divided by how much you started with, that's a fraction that's left, right? So the fraction that's left in the bloodstream is 1/4.